All right, here quiz 6 solutions for Math 112. Two different questions covering two different sections. Here we're solving for a triangle, informally speaking, using SohCahToa. And then on the next page, we'll be talking about some graphs of transform trig functions. So for this first problem, we're told that b equals 2 and c equals 3 in this picture. In other words, this side length here has a length of 2 units, and the length of the hypotenuse is 3 units. And what we're supposed to do is find all these different values. The first thing it asks for is the side length a. Well, we can get this using the Pythagorean Theorem. We know that a squared plus b squared equals c squared, where a and b represent the lengths of the two legs of a right triangle, and c represents the length of the hypotenuse of that right triangle. And since b and c are given to us, we can plug those in here to get that a squared plus 2 squared must be equal to 3 squared. So a squared plus 4 must be equal to 9. So a squared is equal to 5. A is plus or minus the square root of 5. But since I'm talking about a side length, it must be the positive, the square root of 5. And so that's my answer to part A up here, but I'm also going to include that in my picture here, because this picture, now that I have the lengths of all three legs of this right triangle, I can answer all these different questions. So first, the sine of alpha. For sine, you're thinking opposite over hypotenuse, and relative to this angle alpha right here, the opposite side has a length of root 5, and the hypotenuse has a length of 3. So the sine of alpha would be the square root of 5 over 3. The cosine of alpha is adjacent over hypotenuse, and again, relative to this angle, the side length adjacent is 2, and the hypotenuse is still 3, so I get 2 over 3 for the cosine of alpha. Tangent of alpha, you're thinking opposite over adjacent. Relative to this angle, I have opposite is root 5, and adjacent is 2, so I get root 5 over 2 for my answer. The cosecant of alpha, probably the easiest way to get there is to recognize that the cosecant is always the reciprocal of the sine. So all I got to do is take this fraction and flip it upside down. So I get 3 divided by the square root of 5. However, I think I wrote in the instructions that I should rationalize the denominator. So I don't want to leave this as a square root of 5 in the denominator. I instead want to multiply the top and the bottom by the square root of 5. So up top, I'd get 3 times the square root of 5. And on the bottom, the square root of 5 times the square root of 5 is equal to 5. So the cosecant of alpha is 3 root 5 over 5. Similarly, the secant of alpha is just the reciprocal of the cosine. So since the cosine is 2/3, the secant is equal to 3/2. And the cotangent of alpha is just the reciprocal of the tangent of alpha. So just take this fraction and flip it upside down. I get 2 over root 5. Again, I don't want to leave radicals in the denominator, so I'll rationalize and get 2 root 5 over 5 for the cotangent of alpha. For my angle alpha, I've figured out each of my 6 different trig functions, but you might notice that there's one extra part here. Sine again. Oh, that's weird. You already asked me about sine. Right, but I asked you about the sine of alpha up here. Now I'm asking about the sine of beta. Sine is still opposite over hypotenuse, but relative to this angle beta up here, this side is opposite. So while the sine of alpha was root 5 over 3, the sine of beta is going to be 2 divided by 3. Then we move down to the graphing problems. What I'm told is that the graph below has a phase shift of negative pi over 2. So you can think of one revolution as starting right here, and then I do one full revolution and end right here. The way I'd attack this is adding some horizontal lines for the maximum and the minimum height this graph ever achieves, and then another one representing the midline here. Because once you have these 3 dotted lines, it makes it a lot easier to figure stuff out. The midline appears to have a height of -1, so it's given by the equation y equals -1, and that tells me that d is equal to -1. This graph gets as far as 2 units above the midline and 2 units below the midline, and that tells me that the amplitude is equal to 2, and therefore the absolute value of a is equal to 2. At this point, I don't know whether a is positive or -2. We'll figure that out later. The period, which is always 2 pi over b, in this graph, it looks like it takes 1 pi to do one full revolution, from negative pi over 2 up to positive pi over 2. That's a horizontal distance of pi, so 2 pi over b must be equal to pi. So I can solve this equation for b by multiplying the b up to this side and then dividing both sides by pi, and I get that b is equal to 2. And then finally, the phase shift is always negative c divided by b. The problem told me that the phase shift is negative pi over 2, so I know that negative c over b equals negative pi over 2, and since I know that b is equal to 2, I got negative c over 2 is equal to negative pi over 2, and therefore c is equal to pi. Now what I want to do is go back to my starting point here and recognize that since I'm starting on the midline, I'm going to use the sine function to model this graph. And the normal orientation for the sine function is to start out by going up, which this graph does. So since I have the normal orientation, my value of a equals 2. So I've got a, b, c, and d. So my equation is y equals 2, the value of a, times the sine of bx plus c. So 2x plus pi, plus d, which is equal to -1. Here's the equation of the graph pictured. And then finally, question 3, essentially do the same work except you do it in reverse. Now they're giving you the equation instead of asking you to come up with the equation, and asking you to come up with the graph instead of providing you with the graph. Well, just from looking at this equation, here's my value of a, b, c, and d respectively. So a is 3, b is 1/2, c is pi over 2, and d is -1. And with these 4 values and the formulas that I have for amplitude, midline, period, and phase shift, I can answer part A here. The amplitude is always equal to the absolute value of a being equal to 3, so it's the absolute value of 3, or just 3. The midline is always given by the equation y equals d. In this case, d is -1, so the equation of the midline is y equals -1, or just -1 is fine. The period is 2 pi over b, or 2 pi over the absolute value of b if you want to be really picky. But since b in our class will always be positive, you don't have to worry about these absolute value symbols. I get 2 pi divided by 1/2, which is equal to 4 pi, if I divide these by multiplying by the reciprocal of the denominator. And then finally, the phase shift is always -c divided by b, so -pi over 2 divided by 1/2 in this case. Again, multiply by the reciprocal of the denominator, and you get -pi for my phase shift. I got amplitude, midline, period, and phase shift, and I know I'm modeling the cosine function here, so I can come up with the graph. Start with the midline, that's given by the equation y equals -1, shown as this dashed line here. And from that midline, because the amplitude is 3, I want to go up and down by 3 units to signify my maximum and my minimum values. I now have all my guidelines in the vertical direction. Now I'll worry about the horizontal direction. My phase shift of -pi tells me that I can start, if I want to draw one full revolution of my graph, over here at -pi. And since the period is 4 pi, I have to travel a horizontal distance of 4 pi from this -pi. So 1, 2, 3, 4 pi to leave me all the way over here at 3 pi by the time I finish one full revolution of this graph. Now everything's laid out so nicely, I can just sketch the graph. Again, this is the cosine graph, so that means I don't want to start on the midline. I either want to start on the maximum or the minimum. The way I figure that out is whether I have the positive or the negative orientation. Since my value of a is a positive number, I have the normal positive orientation, so I'm going to start out up here at a maximum value, and I'm going to finish at that same maximum value. And halfway in between those two maxima, I want to achieve a minima. And halfway in between each of the maxima and the minima, I want to be back on my midline. With these 5 points, I can pretty easily sketch one full revolution and be done with this quiz. Something like this would be a perfectly acceptable answer. However, I'm going to go a little bit more to indicate to the reader that this continues infinitely far in both directions, draw a couple arrows, and call that good.